Yeah, I know we've explored a lot of planets, or I would say planetary bodies that do have specific characteristics, most especially containing water, like for example, the likes of Jupiter's moons and that of Saturn. But most importantly, looking at this particular article that was released a couple of days ago about a particular exoplanet that was actually discovered couple of years ago, but then a new data that shows some fascinating discovery about what this exoplanet is made out of is really fascinating, coming from this particular Montreal PhD student, and of course in collaboration with his supervisor. It's really fascinating to see how the University of Montreal has this particular department that is regulating a specific telescope, and this is really instrumental because observing this particular exoplanet really shows some interesting results that we're going to dive into, how this compared to Earth in terms of the composition of that particular ingredient, and most importantly, how is this going to shape our understanding and the future exploration of this particular exoplanet with regards to how this might actually be a nice origin story for the fostering of life on that particular planet. Kind of similar, of course, to what we have on Earth, and how is that going to be compared with other moons that we know of in our solar system, mainly Jupiter and Saturn. So let's dive into this particular video. Now, these scientists, they use this particular observatory in Montreal that contains a specific telescope that is called the Space Telescope to observe and understand more about this particular exoplanet. Now, this exoplanet name is known to be called the TOI-1452 B, and this is really instrumental in terms of how this exoplanet is going to be compared to that of Earth. Now, they discovered, yes, the size and the radius of this planet, and what they figured is that the size of this planet is 5 times more than that of Earth. However, it is less dense than Earth. That causes the question how, despite it is large, 5 times larger, the mass might not be the same as that of Earth. It mainly might be less than that of Earth. So therefore, it might be suggested that water may have a huge proportion component to that of this particular density. And this is going to be fantastic as you look closely that yes, of course, Earth has 70% water but makes up 1% of its mass. This particular exoplanet is suggested to have 30% water present and mainly ocean, but in this case it might actually account for way less percent in terms of the proportion in terms of the density compared to that of Earth. So it's going to be interesting to see how they're able to actually dive more into this particular planet. And of course, we know that on Earth, according to evolutionary scientists, they state that actually life started on the ocean, and after millions of years, that leap to land was a huge step in terms of that evolution. And so in this particular exoplanet, is there potentially a lot of aquatic animals that are present right there, maybe some seabirds right there as well. Not seabirds, birds there as well. We don't know that for sure, but it's really fascinating to see that particular analysis of Earth and how that's going to be compared to that of this exoplanet if more research is going to be delved into this particular observatory of this exoplanet. So it's really fascinating to see that yes, of course, in terms of this particular planet, in terms of the location of this exoplanet, it is known to orbit 2 stars, and this orbiting of 2 stars is not so far from the Draco constellation, and this is about 100 light years away from Earth, which is not too far. I mean, compared to all the view of this James Webb telescope that is producing results that is millions of light years away from Earth. This 100 light years away is actually close to Earth. In terms of the orbit of this particular exoplanet's radius, is really known to actually have a binary solar system because it has like 2 stars, and so it's known that days tend to go by really fast on this planet, which says that it is 1 year is only 11 days, which is interesting, which is like 8 times less than that of Mercury's orbit around our solar system, which is wow, mind-blowing. Now, speaking of the 30% of water that is present on this particular exoplanet, it is pretty much on the same level as that of Jupiter's moon, which is Ganymede, and that of Celestial moon for Jupiter, and for Saturn's moons, which is the Great Titan and Enceladus moon. So it's really fascinating to see that yes, we do have our own solar system containing specific bodies that have water outside of Earth, mainly moons, but how those moons, we can actually have analysis of those moons and compare them with that of this particular exoplanet that is 100 light years away from us, and those comparisons can also give rise to the atmospheric conditions of those particular systems and how that can actually impact its stability of life form possibly in that particular exoplanet relative to those moons right there. So this can actually be a nice way for them to have other collaboration with James Webb Telescope, because the James Webb has its own instrument that is able to detect atmospheric conditions like the one that it produced over a couple of weeks or days ago about an exoplanet that has atmospheric water present there. And so this actually can help to understand more about this exoplanet here, which we actually, all these Montreal guys, were able to discover in terms of the water composition. So I hope you found this really informative in terms of this particular video concerning this exoplanet, how it is compared with our Earth, and also the composition and the future of this planet in terms of exploration and also potential for life in there, mainly aquatic animals, since there are a lot of water present, little to no land there. All the same, found this really informative. Hit a comment down below, let me hear your thoughts. By that way, I can talk to you all soon. Stay smart as always and believe in yourselves.